Hi, hello guys. Let's upload another video on Teach to Educate. The previous video was a Bluetooth one, so let's start with another video which is known as a Turing machine, which comes in our formal language automata theory of 5th semester computer science. So what is actually a Turing machine? Turing machine, it is a simple mathematical model for designing a system architecture. So it can perform some basic calculations, and it is also called as a computing machine. Yeah. So what is actually a Turing machine? How is this architecture designed? It's actually a single tape of infinite length. It goes on. The tape is divided into smaller parts which are called cells, and each point and to access each cell we have a particular pointer to access each of the cells. This pointer can be used to move right and also left. Each cell will have some of the character to be checked. For example, if we want to check a string of characters, we have to match a particular string of characters, then we will assign each character into one cell. For example, if you want to scan a particular string called ABA, each cell will have A, B, and A, and these string things will be matched. The twist here in the Turing tape is the starting of the tape and the ending of the tape will be with a unique symbol, which I have considered to be as B. It is a unique character which defines the start and end of the string of a particular string like ABA. This is actually the string that we are going to match up. So let us take up a small definition of a Turing machine. Turing machine is defined as a machine of Q, F, delta, sigma, q naught, b, gamma. So these are the states that defines a Turing machine. What is q actually? Q is a set of states that we are traversing from one thing. The states will be discovered in the later part. F is the final states. Delta is the transition states. How is one state transiting from one state to another? And q naught is the initial state, and sigma is the input symbols that we are using in. Here ABAs are input symbols. These are the things that we are giving in. And B defines the input symbol that is present in this tape. And gamma is the set of symbols that is present on that tape. And going to the later part, let's take up a question for solving a problem using Turing machine. Let's take up a language which is defined as a power n, b power n, defined as n greater than or equal to 1. So basically the language is what? A power n, b power n. That means if n is equal to greater 1, which is the basic criteria, a and b is a valid string. Again a, b is again a valid string. So it goes on like this. So how do we detect whether this kind of strings are they valid or not? So let's try using it in the Turing machine. Ta-da! So starting with the Turing machine, we will take an example string as A, B, B, B. Let us take 3 A's and 3 B's which are equal numbers as per our question. Our question was A power and B power n greater than or equal to 1, which is matching the condition. 3 A's and 3 B's both are equal. So how do you do it in a tape? Let's take up a state called Q naught, which is the initial state, first state. Let's take it as a starting state. Then on finding or detecting 1A, it has to replace that symbol by an X and it has to move right. Confused? Right. Consider this as a set of cells. Starting symbol is B. Each symbol is A, B, B, B. Again it ends with a B. So as soon as I encounter this A, I have to replace that by an X and have to move right. The pointer is initially pointing here. Again after detecting another B, which is because after I cancel one A, if I cancel another B, I can evaluate that both are of the same length. I'll go to a state called Q1. Again on detecting A, I won't do anything because I need to cancel another B. So on detecting another A, don't do anything, just replace it by an A and move right and keep on moving right. Q2, again keep looping another A, another B is found. As soon as you find another B, this B, you have to replace it by an Y and move left now. You replace it by a B and you are moving left. You move until you find another X. So you keep on moving left until you find a X. As soon as you find an X, you go to a state called Q4 X. On detecting X, replace it by an X and move right. You come here. So again the same procedure will start. It comes back here. Again A is replaced by X and move right. Same thing, and it does close mode.